4. Today we'll be focusing on the section Kinematics. We'll be focusing on the July 2021 past exam paper. This is question number 1 in the past exam paper, and the section that we'll be focusing on is relative velocity. If you'd like to receive more videos on this section, Kinematics, relative velocity, or the subject Engineering Science and 4, please click on the subscribe button below. Take a look at the question. The question reads as follows: that a bus and a truck leave simultaneously. That means they both leave together from a fork in the road. The truck travels northeast at a velocity of 85 kilometers per hour, and the bus travels directly east at 104 kilometers per hour. Calculate the velocity of the truck relative to the velocity of the bus. So the key word that they have used in this section is relative. Their solution and how to calculate the velocity of the truck relative to the velocity of the bus. So the first thing you need to do in this question is actually take each object and write down its velocity. So you know the velocity and you know the direction, right? So we have the truck, it's headed northeast, moving at a velocity of 85 kilometers per hour. Once we have done that, the next thing we're going to do is draw its velocity on a Cartesian plane so we can break it up into its vertical and its horizontal components. So your Cartesian plane is a simple x and a y axis, and instead of labeling it x and y, we are now going to label it north, south, east, and west. Also, don't forget to put your positive and your negative signs, as this is very important in helping you to calculate the direction. Remember, the velocity is a vector. It has both magnitude and direction. The positive and the negative signs help us to determine that magnitude and direction. So the first thing we need to remember in this question is the truck is moving northeast. So what does that tell us, right? When an object is moving in between the Cartesian plane, in the middle or in the center of the Cartesian plane, in this case northeast, it's in the center of two directions, which is north and east, or in the middle of two directions, the angle there is 45 degrees. So this is important for you to remember, as this will not be told to you in the examinations. Okay, so once it is moving northeast, southeast, southwest, or southeast, southwest, northeast, northwest, the angle is 45. The drawing of the angle is very important, which means in this case it's moving from north to east. So if it's moving from north to east, that means the angle is lying here on the north side, which is the vertical component. For our calculation, what is very important is to make sure that when we work with the angle, we always work with the angle that lies on the horizontal side. Why do we do this? The reason why we do this is because when we work with the angle on the horizontal side, it then helps us to calculate the vertical and the horizontal components very easily using this formula. The vertical component becomes plus or minus v sine theta. The horizontal component becomes plus or minus v cos theta. So if I want this angle here lying on the horizontal side, what I will now do is say 90 minus 45. My angle here is 45 degrees. Okay, so if I look at this, so if I want the vertical component, we can just simply draw out the triangle like this, where I now know it's going north, east, and this is my angle of 45, and this long line here on the hypotenuse side actually represents my velocity. So my vertical component is going to be 85 sine 45. Now how do we determine the positive or the negative sign? Okay, we look at the first direction is north, so if it's going north, the sign there is positive. That is why my vertical component is positive 85 sine 45. Horizontal components, v cos theta, it's 85 cos 45. It's on this y-axis, which is east, and if it's going east, it is positive. We are also provided the bus, and we know the bus is going east at 104 kilometers per hour. Okay, and so I have drawn it just like this, which means here what is happening? The vertical component is not going to be there because it's only moving on a straight line horizontally. Okay, it's only going to have a horizontal component. So let us continue with the question. It says calculate the velocity of the truck relative to the velocity of the bus. So this is a very important key statement. The word relative is very, very important. So when we see the term relative, what do we need to do? When we see the term relative, it means we need to change the directions for one of the objects, and we need to change them to the opposite direction. Okay, so whatever direction it was originally moving, we now move it to the opposite direction. How do we know which one we need to move? Whichever object comes after the term relative to, that is the one we need to change. So in this case, it says find the velocity of the truck relative to the velocity of the bus, which means in this case, I need to change the direction of the bus. So the bus was originally moving east. If I move it to the opposite side, it means the bus is now going to go west. Okay, so the direction I'll be using for the bus in this calculation is going to be west, because it says relative to the velocity of the bus, which means the direction of the bus needs to be changed. So as stated earlier on, it is not moving vertically. The vertical component is 0. It is only moving horizontally, and still since it's moving on a straight line, we do not need to use this formula here, sine theta or cos theta. We only use this formula here when the angle is between 0 and 90 degrees. Okay, so the horizontal component is going to be 104, and if I now look at west, the sign for west is negative. So in this case, the horizontal component is going to be minus 104. So my horizontal is going to be minus 104. Okay, once you have done this step where we have broken up each of the object's velocities into its vertical and horizontal components, it means we are now ready to calculate the relative velocity. Remember, velocity is a vector, it has magnitude and direction. So we want to calculate magnitude, we use the theorem of Pythagoras, and the formula we use there is square root sum of the vertical component squared plus sum of the horizontal component squared. Please make sure you remember this formula and study it for the exam, as this formula is not on your formula page. Okay, so we're going to first start off by calculating the sum of the vertical components. So if I look at the vertical component of the truck, it's going to be 85 sine 45. If you put this into a calculator, it's 60.104 kilometers per hour. How do we get the direction? The sign in front here is positive. Okay, so the positive signs here that I have is north is positive and east is positive. The one that I'm looking for is vertical. Okay, north is moving vertically, so the sign in front is positive. So that is why the direction here is north. The next thing I'm going to be looking at is the horizontal components. So for the truck, it's 85 cos 45. And remember, the bus is moving west, so the horizontal component there is minus 104. And if I calculate this, I get minus 43.9 kilometers per hour. Okay, now here I have a negative sign. So what am I going to do? I look at the negative axis. I have west, which is negative, and south, which is negative. I'm looking for the one that's horizontal. Between these two directions, west is on the horizontal axis. So therefore, the direction of both the horizontal components moving together is going to be west. Right, so now that I've calculated the sum of the vertical, we've added them both together, that is sum, and the sum of the horizontal, I can calculate the magnitude of the relative velocity, and it's going to be positive 60.104 squared plus 43.92 squared, and I get the relative as 74.429 kilometers per hour. Okay, when I want to find the direction, I use the formula tan theta sum of the vertical over sum of the horizontal. So it's going to be 60.104 divided by 43.9, and my angle is going to be 53.856 degrees. Okay, when I give the angle, I also need to say whether it's going north, south, east, or west. So what am I going to do here? Okay, so very simply here, I'm going to say that the starting direction from the horizontal to the vertical side, the horizontal is west and the vertical is north. So the velocity of the truck relative to the bus is going to be 74.429 kilometers per hour, and it's moving at 53.85 degrees west of north. Thank you for watching this video, and if you'd like to receive more videos on the section or the subject, please continue to subscribe to this channel.